Solar power.
How are you doing, Dr. So? What are you going to be teaching today?
I'm going to be teaching about solar energy. Would you like to learn the process I'll be teaching during the course?
Go ahead.
Okay, here we have the sun. Then we move down to the light rays, which hit our photovoltaic cells, or solar panels as most people know them. The solar panels convert the sunlight into electrical current through chemical processes, and then the currents get moved to our battery source. And in this case, because we're using less carbon-based fuels, it kind of cuts down on our CO2 levels and improves our O2 levels for the world.
All right. So what are these solar panels made of?
The older solar panels are made out of a silicon-based resin material with certain chemicals in it to make it photoluminescent.
Okay.
So the newer solar panels are actually made out of nanoparticle. And in this case, the nanoparticles allow for a better efficiency of the sunlight to electrical conversion. It also allows for the panels to be much lighter weight and more flexible. Similar to this on the table that I have here, this is going to be my representation of the new panels.
Oh, okay. What does this mean for the environment?
Well, what this really means is that there's going to be a cut in CO2 levels in the world. But for the true answer, you might want to come back and visit my class when I'm actually teaching the lecture, and then I'll be able to show you through the lecture.
Well, that sounds very good. I might have to do that.
Okay, good. Thank you. Oh, hey doctor, how are you?
Hey, Dr. So. I was afraid I was going to miss the lecture.
Well, you missed most of the lecture, but you can at least see the students' responses.
Okay. I'll just have a seat over here.
Yeah, no problem. So does anybody have any questions? Yes, Danielle?
So we learned that the silicon manufacturing process uses more energy and also uses cooling during the process, which obviously relates to more emissions and will cause a defect in the environment of the water that it's pooling from and that it's sending the water back into. But are there any other environmental issues related to the manufacturing, transportation, or installation process that we should know about?
Wonderful question, Danielle. Nanoparticles don't need to be cooled while being formed into the photovoltaic cells. And because of this, it cuts down on the water aspect of the environment that you were speaking about in your question. You will have the same amount of transportation, but you'll have larger amounts of photovoltaic cells on each load because they're about a quarter to half the weight of the old silicon ones, which, if you do the math for it, then changes up how much carbon emissions you get through the transportation process of the material. Are there any other questions? Kyle?
Yeah, I just want to know how much we can improve the lifespan and the efficiency, like in numbers.
The lifespan of the new nanoparticle solar panels is about double that of the old silicon ones. The old silicon ones were about 15 to 25 years, somewhere within that range. But the new nanoparticle ones are somewhere between 35 to about 45 years. So you basically doubled the life expectancy of these cells, which allows for less production of them, but they also last longer than the older cells. So they're still out in the field for the same amount of time. Your other question with the efficiency. The efficiency of the solar panels is about, I would say, 25% more than that of the old silicon solar panels. So does anybody else have any other questions? Go ahead.
What does this mean for solar power and nanotechnology in the future?
Okay, so to answer your question about the future of nanotechnology and solar power, basically the new solar panels will be thinner and more flexible, which allows for greater applications, as I stated earlier in the lecture. But because of this, there will also be lower costs throughout the entire manufacturing process, which allows for cheaper, more reliable energy throughout the world, where people might not normally have it now, but in the future could be a possibility. And with looking towards the future, you also have lesser CO2 emissions. So with lesser CO2 emissions, it's better for the environment and leads to a brighter future. Solar power.